This conference will now be recorded.
Hello everyone, good morning. Any doubts from previous topics? Today we are going to discuss about modularization techniques. So what is this modularization techniques? Why we have to learn during your ABAP programming course, and what is the importance of this? So modularization techniques are nothing but to improve the readability of your code and to reuse your code. That's why we have this modularization techniques. So what is the meaning of improving the readability of the code or reusing the code is, let's say you got a requirement to perform some arithmetic operations. So someone asked you to write a logic, they wanted to perform arithmetic operations. So what you will do for this, you'll go SU38 and you'll create a program of type executable, and then you'll write a program to perform this arithmetic calculations. So for that, you will divide your code into three blocks. One is declarations, and second block is for operations, and third block is display part. After that, you'll write your logic. So to perform arithmetic calculations, what are the data objects is required? So required data objects you will declare with the data keyword n1 type I, n2 type I, and then you will perform your operation section. So if it is addition operation, you will write n1 plus n2. And to display this value, you will use write keyword along with your data object. So when you look at the code to perform a simple arithmetic calculation, so at least you have written 10 lines of code, right? And if you think about the same requirement, it's a big requirement, like you wanted to get some 3-4 tables data and perform some huge calculations and then send information to a third party system or a middleware system. In that case, you may write logic ended up with 100 lines of code. So writing more number of lines is not the problem here, but what is the problem is, so once you completed with your code and someone in your team wanted to check the way you have written or what you have written, so is there any unwanted variables used in the program, or any problematic statements are there in the program, or if any corrections your senior going to uh, propose, so that other person can easily understand your logic. So if you go and see, for your point of view, you know, because you are the one, you created this program, the lines, everything, you know what is the purpose. But for others, when they look into your code, so they will see like a huge number of lines, so they will need some time to understand. So either your help or by reading the each and every line, then only they'll come to know. To improve the others understanding, not by you who written the code, to improve the others understanding, so that what you are going to do is you are going to use modularization techniques. So if you use the modularization technique, what is the advantage is, so if it is 10 lines or 100 lines or 1000 lines, those lines of code you can convert into 3 or 4 lines. So others who go and see your program, they can see only 3 lines of code. So obviously inside these 3 lines, again, your logic will be there. But overall, when they open your program, it's like simple. So in one line it says all the declaration parts are there. In another line it says logic part is there, and in another line it says a display part is there. So when it is only 3 lines of code in your program, it is easy for others to read what you have written and then to propose if any changes are required. That is one reason. To improve the readability of the code, we need modularization techniques. And second thing is reusability. So reusability mean your purpose of this program is to perform some arithmetic calculation. For that, you forget about the declarations. Main part where you will spend more time is building the logic. So in this case, it may be a simple logic, but there are cases like there is some table where we will maintain the periods. So based on the period, you have to calculate the number of months. Based on the number of months, you have to build a logic. So mostly logic is the place in your program where it will take more time. To build the logic, you have to spend time to prepare and to achieve the business needs. So wherever you are spending time, that must be reusable, which means some other day again after 1 or 2 weeks again one more requirement comes. In that requirement, one of the part, the same logic like arithmetic calculation in that program also they are doing. So when it is required to perform arithmetic calculation, you are not supposed to go again do the initial work in the initial day how you have design program to perform the calculation. After 1 week also again the same declarations you are doing, that is not the correct way. So your code, once you put some efforts and build some logic, so this logic will be reusable in any number of times. When the same requirement comes, you no need to spend that much of efforts. You have to simply pick that logic and use in your program. So that is called reusability. So whenever you are creating a program, you have to keep in your mind those are 2 points. One is your program must be readable. It improves the readability of the program, and the way you are writing the logic, that logic must be reusable. You have to build your program in these two aspects. To achieve these two aspects, we have to use modularization technique. So hope you understood why we have to use modularization techniques. So now, okay, so we have to improve the readability and to reuse the logic, we are going to use modularization techniques. Then what are those techniques are given in SAP ABAP. So these modularization techniques are includes subroutines, function modules. So these are the modularization techniques which is we received from ABAP programming language. By using these modularization techniques, we can improve the readability of the code and reusability of the code. So before going to the each and every technique, so first I'll show you any one existing program where how they have modularized the source code and how the logic they reused in another programs with some standard examples, and we will go and observe in a standard program. Let me log in into SAP. So SE38, where we will see or where we will write the programs. So if I wanted to check any existing program, so either you have to provide some name and then search on F4. So let's see sales. Do we have any program on sales? So these are search option asterisk we will use. So any program which is with the sales, we can see. Click on F4. sales order F4. Utility function for sales order. Let me check this one. So if you see, uh, there is a logic which is developed. Okay. So the purpose of this logic is change the sales order. So whenever anyone wanted to change sales order through program, so you can do it by using this piece of logic. So this logic was developed to change any sales orders information. So if you observe this, there is a logic to change sales order information. So this logic, where they kept in a function model. So function model is one of the modularization technique. So why they have kept this change into this function model? Because there are n number of processes, n number of programs. They need sales order change. So during the outbound delivery or during the billing. So sometimes they wanted to do the changes. So whenever they need change in that particular program, so along with that logic, if the logic requires sales order change, then simply they will call this existing function model, which is one of the modularization techniques. So they are not going to write inside the logic again. So to change the sales order, we have to write this logic. But what they have done, they written this logic once in a while and kept it in a function model. Now, wherever you got a requirement to change the sales order, again you don't need to write enter this logic into your program. You simply call that particular function model and then use the logic. So this is called reusability. So whenever you write any program, always recommend that use any one of the modularization technique and make your logic reusable. Don't write directly in the program. So even if you feel that is not going to use by any other programs, then in that case you can use it in your program. If you feel that logic may use some other cases, then definitely use modularization technique. So when you use modularization technique, your source code will be reusable. And also, if you check here, so they have used function model. So there is a requirement for that. They have written some logic. So only we can see the declarations, but logic part you will not see in this program. So logic they have kept in a function model, and that function model they are using it. So if anybody look into this program, they can easily understand. So maybe it is 29 lines, but literally if they written, it may be ended up with some 1,000 lines above. Each and every function model has so many lines of logic. So your program must be readable. Readability should be there, and also reusability should be there. So how can you achieve this readability and reusability is by using the modularization techniques. So here subroutine. Subroutine means perform. So this is a subroutine program. So subroutine program also they have handled logic. So inside we have logic. They are not writing directly at the outside. And if you can see this program, they have used multiple places. I think here only one place. So see, they have designed one time and they are calling the same logic in multiple places, multiple programs. So this is called reusability. So always you have to write your code to improve the readability and reusability. here they have used include. Include is one of the modularization technique. So inside this, there are so many lines of code will be there. So one of the modularization technique we will discuss now, that is include. So includes or belongs to modularization techniques. Includes or belongs to program type I. So these are not self-executable programs. And this includes must be used in executable programs. So mainly includes are used for declarations, means data objects creation, and mainly used, but which means always it is used for declaration. It is not like always used for declarations. So you can use it for your operation section display part also, but mainly includes are preferred to use it for a declaration section. And this program type I, and how includes will be called is, so include followed by your include program name. So how include program will be called from executable program is include followed by include program name. So directly also you can create include program from SE38, but when you are creating program through SE38, you have to use program type as I. So normally previous cases we created programs which are of type E. Type E means executable programs. Type I means include programs. So those are not self-executable. So we will see, we will write one program and then use any one of this include concept into our program and see how the readability of my program will improve, and how can we create a include program inside of the main program. So execute SE38 transaction and create a program, give some meaningful name, modularization technique, which is used to create include programs. So click on create. So modularization techniques. So this is program to understand modularization technique. So here I'm taking executable program. First I'll create a executable program with some purpose. After that I will modularize my source code. So now my program purpose is perform, write a program to perform arithmetic operations. So this is my program requirement. So I need to provide an input screen where users can enter values. So for input screen, I have to use parameters. So p underscore n1 type I, p underscore n2 type I. And then data keyword, which is used for result operation, result type I. And this is my declarations. And now operation section. Case. So I'll write one more field here. P underscore function type C. And I'll take this as 3 characters. So pretty print, save. save, pretty print. So in operations section, case p underscore function followed by end case. So in between, I'll write when addition, when subtraction, when multiplication, when division. So when addition, result equal to p underscore n1 plus p underscore n2. So copy this. When subtraction minus when multiplication into when division divided by. So write res. So pretty print, save, check, activate. So what I have designed now is I created one input screen. So input screen will be created with the parameters keyword. So parameter is a keyword which is used to provide input screen. So this parameter keyword, it will generate input screen where you can enter your inputs. So we have created three parameters keywords through we have created three input parameters. One is n1, n2 and functionality function key. So which is always like p underscore n1 p underscore n2 like that? No. So for my naming conventions I have given, so whatever it is in upper characters, this is called syntax, and whatever you see in the lower characters, that can be replaced with your own naming convention. For my naming convention, I have chosen p underscore n1. You can give input 1, input 2, like that. It will accept. So parameters keyword, what is this keyword? This keyword is to create input screen. So I have input screen which is created with the help of parameter. So after creation, you can see my screen which is showing as these are technical field names. But in the input screen, it is always recommended to show the not technical information, some meaningful information. So how we can change this is, you can go to utilities, go to menu bar, go to and text elements, selection text. Choose this and here give some appropriate name. So this is arithmetic, and then this is input 1 and this is input 2. So save, check. So there is no check. Save, activate and come back. Now activate once and execute. So you can see this is input 1, input 2, this is arithmetic function. So what I am going to do now is I'll enter inputs and then I'll write what needs to be done with these inputs. If I wanted to perform addition operation, I'll write key as addition, add. If I wanted to do division operation, I'll write it as div. So this is my functionality, what needs to be done. So after that, you can see here, these are my inputs where I can enter input values, and result has to be come into one variable, right? So for that, you have created one more in a data object of type variable. So now this res is ready to capture your result. So after 4 or 5 addition, so 9 will become as a result, right? That will capture into this data object. So here what I have used a case statement. So what is this case statement done is, so case is always referred to the field and when is referred to the value. So case field name. So we are referring to this field name. So whenever we enter a value into this field name, so when will we go to that particular value. So if I enter add, so this case statement, it will ask when to execute that particular addition logic. If I enter subtraction, it will go to this line. So it will not check line by line. So if suppose I have entered a division operation here. So when I enter division operation, case saying that this particular field has division. So when it have value division, so directly it will go to the when with the division. So it will not go first line and check whether what value you have entered. So it will not do like that. So directly based on the field value whatever you entered, it will go to that particular when statement and perform the respective logic. That is the advantage of case. So now this is the program which we designed. So this program which will perform arithmetic operations. So if I enter 4 and 6, wanted to do addition, so I'm getting value as 10. If I wanted to do subtraction, 4 minus 2, so you need to change here value subtraction. So it will do the subtraction. If I need to perform division operation, so 4 by 2 division operation. And if I wanted to perform multiplication operation, so all the operations I am able to perform. Now I know as I designed this program, so I am able to understand. So there are 10 lines of code or 24 lines, whatever it is, I can able to understand this program is designed for arithmetic calculation, and this is my declarations, and this is my operations, and this is my display part. But we have to write always your logic, whether it is simple logic or a complex logic, in a by using the modularization techniques. So now I will make this program divided into 3 lines only, so that the first condition, modularizing your source code, dividing your logic multiple lines into simple lines, that can be achieved. So how we can make this lines of code 10 or 15 lines into 3 lines? So by using the one of the modularization technique called includes. So I'll use include. So include is the command which followed by include program name. So I'm creating a program. So include program for declarations. Okay. And I'm creating one more include program. This is for my operations. And I am creating another include program. So this is for my display part. So I am creating 3 include programs. So these 3 include programs you can create directly from SE38 by giving include followed by include program name. Otherwise, you can create directly through SE38 and provide your program name, and then click on create, choose the program type I. So one program I'll create from this, and another program I'll create through SE38. So first one, so let's save this program, pretty print, save it. So when you go for check, it will throw error saying that this include followed by declarations or operations are not found. So maybe this declaration is exist. That's why it is not giving the error. Let me check. Yeah, this is exist. So I'll give one more letter. So this is does not exist. Yes. So when you do the check, it will throw error saying that declaration, a program is not found. So which means it is not created. So you need to create now. So double click on it so that system will take you to create the include program. So click on yes. Now you can see automatically the program type was chosen as include program. Save it as a local object, and this is your include program. Just save and come back. And this operation is also not there. If I go save, check, I can see operations not found because declarations just now we created. That's why it is not saying declaration program is not exist. So what it is saying now, operation program is not exist. So if you want, you can double click and create from here. Otherwise, you can copy this name And as I said, open SE38 another window and enter your program name. Click on create. This is include program for operations. Now the program type you have to choose as include program and then save as local object. Now save it and come back. So this is operation program is completed. We have created. Now if you save, check, then what it is saying, include display is not found because declaration was created and operation program also created, but a display program is not created. That's why it is throwing error. So declarations we created from here, from the program, and operations we created from SE38. Now the third one I am going to create through program only. Click on yes. So automatically it was proposed include because you are using include statement. That's why it is creating include program. Now save it. So why I said always save only, because we are going to add some logic in every program. So now we created 3 programs. One is declarations and another one is operation and another one is display part. So all these programs are in status inactive, including the executable program. So when you need to make this active is once after the code segregation is completed, then do the activation part. So first declarations, I'm removing here declaration part. Save it and then double click the declaration program, add your declarations here. Now save, come back. And operations, remove from here. Save it and write these operations inside the program. Save it, come back. Now the display part, remove from here, save it and write inside this display part. Save it, come back. Now save, check, activate. So when you do activation, you need to choose all your programs. So this is declarations, display part and operations. Choose whatever you created and then activate. What happened? So still in active state, okay. So operation case, okay. So this is not considering. So p underscore function is unknown. Okay, fine. So p underscore function we have here, save, check, activate your program. Now come back, save, check, activate. Operation section, save, check, activate. Come back, display part, save, check, activate. So now you can see all your programs are active. So main program active and your sub include programs are also active. This one active and operation section is active and display part is also active. So once all these 3 and executable program is active, now you can execute and you can perform your operations. So same result it is giving, subtraction, multiplication, execute. So if you come back, so earlier we have multiple lines. Now the total program is divided into 3 lines: declarations, operations and display part. So if anyone come to your program and see, they can easily understand, okay, so you created a program to perform operations and all your declarations in this program and all your operations on this program and display part is in this program. So if any changes they need, they will propose like operation section. You have written something, but there is a problem is occurred. Like users are giving input one, but they are not giving input two, and they are trying to do the division operation. So system is throwing dump. So to handle this, you need to do some corrections in your program. So to make the corrections, then what we have to do? So operation section is the one where the logic part will happen. So we'll go directly here and then we will see what is the logic implemented. So when division operation is performed, what you are doing, they will check. And here they will implement a condition. So if p underscore n2 is initial, which means when there is no value given for p underscore n2. So in this case, what they do, they will write a message, please enter value for, or please enter value in p underscore n2, and message type is error. Else, if there is a value was given for p underscore n2, in that case, else statement will trigger and it will perform the division operation. Save, check, activate. So now you can execute this. Now provide input for p underscore n1, not giving any value and going for the division operation. So you can see, please enter value in p underscore n2. So system will give proper message and it will not throw any dump. So it is easy for others to do the validations inside this. And some other program wanted the calculation part. So some other developer, he also performing a program where he is doing the logic part. So Sanjay, like Arun, he is doing a program to perform arithmetic calculations. So his program is to also perform arithmetic calculations. So when he wanted to do this, so he no need to write everything. Directly he can go here, he can use that include whatever you created for operation section. What is that include we created? OPER. So you'll use this operation directly. So obviously when you use this operation logic, so these inputs you have to provide. So no need to write the logic part, only to perform the logic, what are the inputs are required, like this data objects, what it is required, you just create it. Otherwise, if you have the another include for the declarations also, like Z declaration is there. So this include you can directly call into this program. Include Z declarations. So pretty print, save, check, activate. Now he has declarations, he has operations. So now he can enter the values in his program and then display the information. So no need to write anything. Already implemented logic, he can use it in his program also. So display part, what he will write Arun program output, RES. Save, check, activate. So when you perform arithmetic calculation for 6 addition, execute. So this is from Arun program, and the same one you can achieve 3, 6 and multiplication, execute. So this is from another program. So two different programs can use the same logic without any writing again the same operation. When another person come across the same situation of writing the same logic, he no need to spend time to write the entire logic. Instead of that, simply he can call and he can use it. So that's where previously I have shown you, right? We have the program sales order. So this sales order program, when you go and see, they have created once and they have used many places. So call function. So this is a function module. So this function module, they have created logic part and they have used in multiple places. So the advantage of modularization technique is you can modularize the source code, simplify the source code. Others can see easily and they can understand. And second thing, you can reuse the source code. These two are possible with the modularization techniques. And we have subroutines in modularization technique. So subroutines we will see now. So subroutines are also one of the modularization technique which we will use. Subroutines are belongs to program type. So these are includes, right? These are subroutines. So subroutines are belongs to program type S, and these also not self-executable programs. So these must be used in executable programs. So what is mean by this not executable? So we created this program, right? Declaration is a include program. So if you directly execute it, you can't execute. So it requires a executable program. So it is asking you to choose any one executable program to execute the lines of code. So directly you cannot execute a include program. It requires a executable program. That is the meaning of not self-executable. And these subroutines used for performing source code logic, mainly used to perform source code logic, which is reusable in the same program. And subroutines are called by statement called perform, followed by your subroutine program name. Obviously, we call this is form or subroutine program name. So when you create with the perform your subroutine program, so automatically system will create a form, end form statements. So in between form and form, you need to write your logic. As like includes subroutines also one of the modularization techniques. So what is the advantage of subroutines is subroutines advantage we can use it for source code logic. So difference between the include and subroutine is so mostly are common, like these are not self-executable, not self-executable, used in executable programs, and this is used for mainly declarations, and this subroutines mainly used for source code logic. And what is not there in include, what is present in subroutine is parameter interface. So parameter interface is only available in subroutines, which is not available in includes. By includes you cannot do any parameter interface, data exchange is not possible. So what is mean by this data exchange? So how you are creating include program? Include program you are going to create with like this, include followed by G declarations or operations. So you are creating include program in this way, right? So after that, one include program will be created with the G declarations, and inside that you are going to write all your declarations or source code logic, something, right? And operations, if you create any include program with operation, so there is an operation program will be created, and inside that you will do your logic part, res equal to n1 plus n2. So this is operation section. So in include program, where this include program is getting called from SE38 of program type E. So there will be a separate program like the arithmetic calculation, so which is of type E. Inside this program, you are creating two different includes, and each include program you have a different logic, right? So whatever it is created inside the include program are called formal parameters. So here N1 is a formal parameters because this is created inside the include program. If any parameter which is created in SE38 main program, that is called actual parameter. So the data exchange between, let's say here you created one parameter res equal to res type I. So you have created one parameter, one data object in main program. So this RES data object is called actual parameter. So actual parameter to formal parameter data exchange is not possible by using include. So includes through what is not possible is parameter interface is not possible. You can't exchange data between actual parameter to formal parameter. But whereas by using these subroutines, the data exchange is possible. You can exchange the data from your actual parameter to formal parameter. So quickly I will create one, I will show you. So I'm going to create a program, modularization technique of type subroutines. So click on create. So this is to perform arithmetic operations and executable program, save as local object. Now save. So here to perform arithmetic operations, I'm going to use few data objects, n1 type I and n2 type I and res type I. And then I'm using a subroutine program. So perform followed by my arithmetic calculations. GARTH calculation. This is my arithmetic. This is my subroutine program. So I am using perform followed by form name. This is the basic syntax, and you can add addition as using followed by your variables n1 n2. So save, pretty print. So perform followed by your subroutine program, and using is the addition. By using what you are going to use, you are going to use your data objects n1 and n2 inside this arithmetic calculation. So double click on this. So system is saying subroutine program not exist. Click on create. Now it proposes two options. You wanted to create a new program, or you need to create this subroutine program in your report itself. So when we will choose the new program is if your program must be a global, like you create once and use it in multiple programs, then go with the new include. Otherwise, if your program only is going to use this subroutine program, then you can choose the program inside your main program itself. So I'm choosing a main program now. So click on continue. So after that, you can see here automatically a subroutine program was created. This is my subroutine program, and this subroutine program is using two formal parameters. So whatever you created in SE38, this is SE38. These called actual parameters. whatever it is created inside the subroutine program is called formal parameters. Now the data exchange is happen between the actual to formal. So I'll write res equal to p underscore n1 plus p underscore n2. So pretty print, save, check, activate. And here I'm going to write res. So here I'll pass some value. Instead of data, I'll use parameters. So parameters n1 type I, n2 type I, which will create an input screen, and I'll create a data. So this is for result operation. Pretty print, save, check, activate. So if I pass value 5 and 2, execute. So I'm getting addition operation 7. So if you see here, let me place a breakpoint and execute. So I'll be giving 5 and 2, execute. So whatever you see, the parameters, data, and perform statement, all these are in SC38 in main program. So this is my main program. Sanjay, whatever we created, this is my main program. And I am calling subroutine program arithmetic calculation. I am using the actual parameters values, n1, n2 values. So if I click on F5, so now I was in subroutine program. So the subroutine program name is ARTH calculation. So if I click on P underscore n1, P underscore n2, I am able to see the values. So these values actually coming from my actual parameters, which is nothing but coming from the driver program SC38 executable program. So this is called parameter interface, data exchange. Data exchange between the actual parameters to formal parameters is called uh, parameter interface, and this interface is possible only in subroutines. It includes this type of exchange is not possible. So if result operation was performed here, and this value, same value which is given back to write, again it will go to write statement. So after perform is completed, now it is triggering the SC38 write program. So what you need to do is you just go today and create a program first to perform arithmetic operations, and then use includes. First, modularize the source code by using the include, and observe how include is used to modularize the source code and to reuse the source code. And second, create the same program to perform arithmetic operations, but here use subroutine program. So subroutine programs are called by statement perform followed by your subroutine program, and using followed by your actual parameters. What are the actual parameters you wanted to use? I wanted to use these two inputs. That's why I'm using keyword. So and then double click. It will create a subroutine program, and you can pass the values after writing the code. Place a breakpoint and see how the values are exchanged between the main SC38 program versus your subroutine program. So even if you are seeing inside the same SC38 editor under the main program, but system point of view, these lines are in SC38 executable program, and these lines are in subroutine program. Two different program system may consider. So we will continue tomorrow. Any doubts today? If no questions, we can wind up for today. Thank you.